Hello my dear students, welcome to today's class. As you can see on your screens also, the topic is combustion and fossil fuels. Okay, in this chapter I am going to tell you about different types of combustion, about flame, about fuels and condition necessary for combustion and of different fossil fuels. Okay, so let us start the chapter now. Okay, can you see on your screens also? Now tell me what is burning. What is burning? Anything जिसमें आग लग जाती है. Okay, जब आग निकलती है, heat and light is generated. Any substance when it is burned, heat and light both are things are given out. That is known as combustion. Okay, so the process in which substance burn in the presence of air, that is oxygen, to give out heat and light is called combustion. Just now I told you whenever anything burns in the presence of atmosphere or in the presence of oxygen, heat and light is generated. That is known as combustion. Okay. Now there are two types of substances based on how readily it can burn. First is combustible substances and non-combustible substances. If I talk about combustible substances, substances that burns in the presence of air to give heat and light are called combustible substances, like paper, wood, okay, coal, LPG. And on the other hand, non-combustible substances are those substances which do not burn. For example, sand. How much fire you add to it, but it will not burn. Okay, you cannot burn water. Okay, you cannot burn glass. Okay, these are called non-combustible substances. Fine. Now the next one, types of combustion. Different types of combustion are there. There are basically three types. Rapid combustion. Let me zoom the screen. Okay. Fine. Different types of combustion. If I talk about combustion, can be classified into three types. First is rapid combustion, second is slow, and third is spontaneous combustion. If I talk about rapid combustion, in this type of combustion, substances produce large amount of heat and light in a short interval of time. Short interval of time is there and lot of heat and light is given out. That is rapid combustion. Slow combustion, in this type of combustion, substance burns at a very slow rate with the production of little amount of heat and light. Okay, but if I talk about spontaneous combustion, in this type of combustion, substances catch fire on their own without the application of heat. For example, white phosphorus, fire in coal mines and forest fires, etc. Okay. Three types of combustion I have talked about. First is rapid, second is slow, and third is spontaneous. Fine. Now, what are the different conditions necessary for combustion, children? I'll tell you about this now. See, for the combustion to take place, there should be, first is very important, presence of oxygen. Okay. In case the oxygen is not there in the air, no combustion would take place. Second is presence of combustible substance. Okay, combustible substance, just now I told you, which catches fire easily. If I talk about paper, it catches fire easily. But if I talk about water, it will never be able to catch fire. Okay, so the conditions necessary for combustion is, first is presence of combustible substance. Next one, presence, let me zoom it. Okay. Now, the second is presence of substance that supports combustion, that is oxygen, and heating the substance to its ignition temperature. You have to heat the substance. Whatever substance will catch fire, it has to be heated. Okay. So the lowest temperature which is necessary for the substance to burn is called its ignition temperature. Different substance has got different ignition temperature. Okay. Substances with low ignition temperature, the substance that can easily catch fire, have low ignition temperature, that is straw, cloth, LPG, biogas, paper. Whereas if I talk about high ignition temperatures, the substances that do not catch fire very easily and have high ignition temperature, for example coal, cow dung, charcoal, are substances that have high ignition temperature. Children, even different substances, they have got different ignition temperature. Everything does not burn on a specific temperature only. Okay. Now there are different activities which have been given to prove that combustion does not take place below its ignition temperature. You can just go through it. There's nothing much to explain in it. Now we'll do a read about firefighting. Okay. You must have seen firefighters. In case there is a fire breakout, what do? You immediately call the fire brigade. Okay. And the firefighters come to rescue. Now they are using different things. First they see what thing has got fire. Okay. Now depending upon the material, they decide what thing they are used to use. Okay. So we know that fire needs three things: combustible substance, air and heat. These fires can be caused loss of life and property. Whenever there is a fire, life and property both are at loss. So firefighters should be brought under fire should be brought under control and extinguished as soon as possible. Fire can be controlled by removing one of these three things. Combustible substance cannot be removed because it has already catch fire. You cannot remove it. Now the two things are left: bringing the ignition temperature down, and second is cutting the supply of oxygen. So firefighting can be done by controlling other two factors. First is, now the precautions while using water as fire extinguisher. In case there is a fire in your house due to short circuit and all, please don't use water at all. In case you are going to pour water on the fire which is due to the electric shock, you will get a shock yourself, because water, being a good conductor of heat and electricity, will not help us, but it will make the thing more dangerous. Okay. Now water is used to stop fire when substances like food, cloth, paper are burning, but water cannot be used. Can you all see? Okay. But water cannot be used to extinguish fire when substances like oil, such as oil in a frying pan or petrol, is burning. This is because water is heavier than oil, and so it settles down and the oil continues to burn. Water should not be used to extinguish fire caused by short circuit or any other electrical disruption. Okay. Now there are different types of fire extinguishers which are available in the market. Okay. I'll talk about it. First is carbon dioxide fire extinguisher, soda acid fire extinguisher, and the last is sand. Okay. Carbon dioxide is heavier than air, so it forms an interface between air and fire. Thus, air cannot reach fire and fire extinguishers. Soda acid fire extinguisher. These types of extinguishers contain sodium hydrogen carbonate and sulfuric acid, which combines to form carbon dioxide. Okay. Then sand. Sand can also be used to extinguish small fire by forming a blanket over the fire and making it deficient in oxygen. In case we want to put out the fire, we have to immediately cut off the supply of oxygen. Fine, children. Now we'll talk about flame. You must have seen the flame. Okay. What is flame actually? All the combustible substances produce flame. The region where the combustion of the gaseous substances takes place is called flame. For example, LPG, camphor wax, when burned, produces flame. The color of the flame depends on the amount of oxygen that is available for burning the fuel. depending upon the type, how much fuel is required, how much oxygen is there, the flame depends upon that. Okay, we get two types of flame. First is yellow flame and the second one is blue flame. If I talk about yellow flame, when the amount of oxygen is insufficient, whenever the oxygen content is low, you will always get a yellow flame. But when the oxygen supply is sufficient, you get blue flame. Fine. Then there are different parts of a flame. A flame can be divided into three zones. Okay. I'll tell you in this diagram is there. Okay. Fine now. There are three zones: inner zone, middle zone and outer zone. If I talk about inner zone, it is black in color. You can see here, this is the candle is there and the flame is shown over here. The inner zone, this is the inner zone. Okay. This is the middle zone and this is the outer zone. Fine children. The outer zone, this is the hottest and the inner zone, it is the coldest one. Fine. Now burning of wax candle. Have you ever observed a candle flame? Let us learn a few important facts about whenever you are burning a candle. First, the inner zone of the burning candles contains unburned wax vapors. So, the middle zone of the flame consists of carbon particles and only the wax vapors burn and not the wax. The outermost zone of the flame is the hottest. Just now I told you, the heat produced from the candle wick melts the wax. Carbon dioxide is produced by burning of wax. Whenever we are burning wax, what is given out? Which gas is given out? Carbon dioxide. And the inner part is the coldest one and the outer part, the tip of the flame is the hottest part of the flame. Fine. Now, different activities have been mentioned over here, which shows about whatever I told you just now, the hottest part, the coldest part. You can just go through it. This is nothing much to explain in this. You can go through it yourself only. Okay. Now, we'll talk about fuels, different types of fuels. Fine now. Can you see on your screens? Okay. Fuels. Substances like wood, coal, LPG that produce heat on burning are called fuels. Anything which produces lot of heat, lot of light, okay, that is called a fuel. Now there are different types of fuel, okay, depending upon their physical state. First is solid fuel, liquid fuel and gaseous fuel. If I talk about solid fuel, wood is there, okay. Coal is there because now the fuel is solid at the room temperature, that is solid fuel. If we talk about liquid fuel, anything which is in liquid form at room temperature, that is liquid fuel. Like if I talk about kerosene, petrol, okay. And gaseous fuel is always gaseous at the room temperature like LPG, CNG, okay. That is all. Gaseous fuel, biogas, that is very common these days, okay. Now, what is calorific value of fuel? That is very important, children. Please go through it very nicely, okay. As we know that all fuel produces heat on burning. That is very true. Whenever any fuel is burned, what is given out? Heat and light. So, but it is not necessary that all fuels will produce the same amount of heat on burning. The amount of heat produced when 1 gram of fuel is completely burned is called calorific value of fuel. This is very important, children. Just go through it. What is calorific value of fuel? That whenever 1 gram of fuel is burnt completely, the amount of heat given out or liberated out is known as its calorific value, and every fuel has got different calorific value. The chart is there, just go through it, okay. Now, what are the characteristics of a ideal fuel. Okay, I'll tell you the characteristic of ideal fuel. It should have high calorific value. It should be cheap and easily available. It should burn easily at room temperature. Its ignition temperature should not be too high or too low. It should not produce harmful gases when burnt, because if it's going to produce harmful gases, then the problem of air pollution would rise. It should be easy to transport. Now, characteristic of some good fuels. The heat liberated by a fuel is measured in kilojoules. Whenever the heat is given out by any fuel, it is always measured in kilojoule. A fuel is considered good if it has a low ignition temperature, has a moderate rate of combustion, is cheap and easily available, does not cause pollution, which is very important because pollution is a major problem these days. So, a good fuel will never cause the problem of air pollution. Produced a large quantity of heat. Fine, children? Now, fossil fuels. Fossil fuels. This is also very important. What are fossil fuels? Fossil fuels are the fuels which are made from the dead and remains of plants and animals which died millions of years ago. Okay, their plants and animals died, and what happened? It got buried deep into the soil, and with the passage of time, with the action of wind, chemicals, air, pressure, so many things all worked on it, and what we got after million of years? Fossil fuels. They are buried deep inside the earth crust. Okay. Fossil fuels are formed from the remains of plants and animals that are buried under the earth for a period of millions of years. Coal, petroleum and natural gas are fossil fuels. We depend on a large number of materials to fulfill our basic needs. Some of them are obtained from nature and others are man-made. Now, types of natural resources. First is inexhaustible and second is exhaustible. Inexhaustible resource. These resources are present in unlimited quantity in nature. For example, sunlight, air and water. They will never end up. But if I talk about exhaustible resources, with the passage of time, the speed at which we are using, we are not aware. We are wasting it. We are not aware that we will not be able to get it back soon. So, these are known as exhaustible resources. These resources are present in limited quantity in nature, for example, coal, petroleum, forest, wildlife, etc. So, with our own mistake, we are losing them at a very alarming rate. Okay. Now, we'll talk about coal. There are different types of coal available, okay, depending how it is made. Okay. Now, I'll zoom for you. Okay. Coal is made up of carbon. It is black in color. Okay. So, children, coal is made up of carbon. It is black in color. There are three different types of coal: anthracite, bituminous and lignite. Okay. There are three different types of coal available. First is anthracite, second is bituminous and third is lignite. Now, how is coal formed? How was coal formed? What happened? Millions of years ago. See, coal was formed by the buried vegetation millions of years ago. It is also known as buried sunshine. As plants decayed, they got buried deeper and sank to the bottom of the swammy areas, piling layers over them. These layers over the years formed soggy, swampy mass called peat. Over the years, the seas and the rivers deposited sand and minerals, and the peat below it got pressurized and resulted in the oozing out of water from the peat to form lignite. Increased pressure and deeper burial of this matter finally led to the formation of bituminous coal, and finally anthracite was formed. Okay. Now, different products formed from coal. Okay. I'll tell you about destructive distillation of coal. Okay, you can see on your screens also now. See children, when coal is heated in absence of air, different products from coal are obtained. Coal को अगर हम air के presence में करेंगे तो what will happen? The coal will turn into ashes. Okay, that will be of no use. But if we are going to heat coal in absence of air, we would be getting different products. In winters, what happened? We are burning coal and all so that the room is heated and all. But at the end, when we are burning the coal in presence of air, what is happening? We are just getting ashes. But in case we are burning the coal in absence of air, we are getting different products. First is coal tar, second is coke, and third is coal gas. And burning of coal in absence of air is called destructive distillation of coal. Fine. Now petroleum also. It is dark and thick crude oil. It is found below the ground in certain areas. Okay. Now formation of petroleum and natural gas. Okay. Formation of petroleum and natural gas. It was formed by the decomposition of tiny organisms that got buried under the sea about millions of years ago. The dead bodies of these organisms got covered by sediments like sand and mud. This high pressure heat slowly converted the buried organism into oil and gas. The fuse thus formed got trapped between two layers of impermeable rocks, forming petroleum and natural gas. Okay. Now, extraction of petroleum and natural gas. How we got this natural gas and petroleum out. Okay. See, you can see on your screens also. Petroleum and natural gas are extracted by drilling holes in earth crust. Wherever wherever we find this petroleum and natural gas, what have we do? We drill holes in the earth crust by drilling big drilling machines are there through the impermeable rocks. The oil which is extracted contains solid, liquid and gaseous hydrocarbons. The crude oil is separated from these hydrocarbons by means of purification or refining. Now, what is the process of refining of natural gas or petroleum? Petroleum is heated in fractional column about 400 degrees Celsius. This column is tall and cylindrical in shape and contains large number of horizontal trays. As you can see here also children, this cylinder is there. See, you can see this cylinder is there and trays are there. Horizontal trays are there. Okay. And what is happening now? You are heating this. Okay. At 400 degrees Celsius now. When petroleum is heated, the vapors of petroleum moves upward and get cooled and condensed at various heights according to their boiling points. This is called fractional distillation. Now, when the this petrol is heated, what is happening? At different, it is rising up, you are heating, it is rising up. Okay. It is rising up, and now what is happening? The petroleum, when it is heated, the vapors of petroleum moves upwards and get cooled and condensed at various heights according to their boiling points, and this is called fractional distillation. So, the different products of petroleum are what all you get? You get petroleum gas, you get petrol, you get kerosene, you get diesel, you get lubricating oil, and you get paraffin wax, and these are the different uses they have given. So, with this I end the chapter. I hope you all have understood it very nicely. Please go through it. Okay, I am so sorry. Natural gas is also left. I am so sorry. I would be continuing now. Uses of natural gas. Can you all see on your screens? Okay. Fine. Natural gas. It is used to generate electricity in thermal power plants. It is used as a fuel in industries. It is also used for domestic purposes. Nowadays, CNG, that is compressed natural gas, is used as a fuel in vehicles. It is used in manufacturing of fertilizers, and it is also used to produce hydrogen. Fine, there are different uses of natural gas, and this natural gas is odorless to detect. Okay, it is odorless, and it is this natural gas is odorless to detect its leakage. A chemical called ethyl mercaptan is added to it to know whether there is a leakage in the natural gas or no. Okay. Now, disadvantages of fossil fuels. Everything has got advantage and disadvantage of its own. Okay. So, I'll tell you about disadvantages now. Now, first is air pollution. The first disadvantage is air pollution. When you burn these fossil fuels, what happens? Different gases are given out which get mixed in the atmosphere and creates a threat to the mankind, to the animals. In case we inhale, we get some of the other problem. Okay? Usage of fossil fuels cause air pollution with the release of pollutants like carbon dioxide, sulfur dioxide, and soot particles. It creates a hazard health problem to us. Okay. Now they are limited availability. Okay. They are limited in nature. But what we are doing due to our carelessness and all, we are using it at a very alarming rate. And what is happening? It is getting duplicated. Okay. So it has to be used wisely. Okay. Another disadvantage of fossil fuel is that they are available in limited quantity only. Fine. Now the next one. So I think with this I have ended the chapter. I hope you all have understood the chapter. Please go through it again. Okay. In case you have any problem, read. As much as you will read, you will be solving the problems on your own. Take care of yourself. Bye-bye.